Thank you, everyone. Max, if you don't mind just making me a presenter so I can share my screen and share the presentation. Thank you for the opportunity to present, and thank you, everyone, for attending.
Definitely. 1 second, you should be a presenter now.
Yes, I am able to show. Just let me know once you can see the screen. Okay. Are you able to see the screen? Okay, let me know if the presentation showed up. Can you hear me?
Yes, we can, and we can see the presentation.
Yeah. Okay, thank you, everyone. So as Max shared today, I'll be presenting about securing Kubernetes clusters. I wouldn't say it's about everything that in regards to securing Kubernetes clusters. It's a huge topic. There's a lot to cover. I'll mainly be covering pieces that relate to networking, authentication, and authorization, and hopefully, maybe in the future, I can cover other features that are available, especially on AKS. Just before I start, a little bit about myself. My name is Ahmed Harb. I have over a decade of experience in areas encompassing like Linux system administration, cloud, DevSecOps, automation, and most recently in the last 3 to 4 years, containerization and microservices, especially Kubernetes. I'm the founder and owner of Code the Cloud, and I'm a senior cloud and DevOps consultant with ObjectSharp. I'm lucky to be a colleague of Max, Dave Lloyd, and others. I've added my LinkedIn profile as well. If anyone has any questions or would like to connect, I'd be glad. So I'll be after this presentation, I'll be uploading this slide deck to the same GitHub repo that I have shared, and it includes the link. If anyone doesn't have the link, I've already posted it in the chat. There's a demo repo that's there. It has all the scripts that I'll be showing and showcasing today. Starting with the secure AKS architecture example. So this is an example. Definitely, it could be much larger than this at scale or in bigger enterprises. I'm just deploying in my own demo environment. So the deployment includes a single virtual network. Within it, there's an Azure Firewall subnet. And there's a subnet where I would be deploying a private AKS cluster, and another subnet where I'm deploying, like an example, Jumpbox VM. But that could be any other workload that you want to be running there. For example, like, sorry. Yes.
Do you mind just using the mouse to highlight the things you're talking about?
Yeah. No worries. So there is an Azure Firewall subnet deployed. Everything will be routed through it. There is additionally an AKS subnet where all the workers will be running. For that subnet, I will be only exposing the ingress through a private internal load balancer. And within the cluster, I'll be running an STO service mesh. The ingress controller for STO will be exposed only as an internal load balancer, nothing public. Additionally, I added another subnet as an example for VMs, where they'll be deployed. A single VM will be deployed in there. I've given it the name of Jumpbox. However, it could be any other workload running, and you can obviously add other subnets and route them through the firewall within your VNet. So this is just a sample, sample architecture to showcase how the functionality that's available through Azure Firewall. So starting with the AKS cluster, it's deployed using a private subnet, as I mentioned, with UDR. So when you deploy AKS clusters, you can either deploy them with a route with a UDR functionality or using a load balancer. If you use a load balancer, it will create an actual public load balancer and route all your outbound traffic through that load balancer. That could be fine in certain environments. However, it's not really secure. It doesn't allow you to control the traffic as you wish. Most enterprises always have an MVA of some kind, and in this case, I'm giving Azure Firewall as an example, where everything will be routed through Azure Firewall, and I will be able to monitor that and leverage all the features that Azure Firewall provides. Additionally, as I mentioned, the STO service mesh will be deployed with an ingress controller that's only private. There's a sample template for an STO gateway object that's deployed. where HTTP will always be redirected to HTTPS, as well as the fact that it will only accept the minimum TLS version of 1.2, because this has become a standard, I believe, since June last year, 2018, I believe. So PCI has made that a standard as a minimum version. So additionally, in the jump box VM, I've added a few examples where there'll be a destination NAT rule in the firewall, allowing only my public IP to be able to access that jump box over a specific port, which is 2222. I put that port as an example, but that can be changed. I will showcase, I will show the script. Everything in there is parameterized, and you can change as you see fit, and do your testing of on your own subscription. Additionally, for the jump box, I've added some application rules where, for example, I allow only the jump box to reach Azure DevOps endpoint, which is dev.azure.com, while the AKS cluster, for example, cannot reach that. So you have all of that control centralized within the Azure Firewall. And as you can see, there is also a DNAT rule where, as you can tell, my Istio ingress controller is going to be only private. However, I have the ability to expose it to the internet through my Azure Firewall. So everything will pass through my firewall. I will map the public IP of the firewall. I add destination NAT rules that map the port 80 and 443 to go to the Istio controller. And at Istio level, I can control all the host names and the subdomains and everything. Obviously, in enterprise, you can add, and you should definitely add a WAF of some kind, whether it's Akamai that you use for external access, or whether you can leverage also obviously app gateway from Azure or front door to expose with additional WAF features, as well as tracing the source IPs of your clients and so on. In the example, I'm considering myself as an internal user, and whoever runs the script will become like an internal user. The definition of an internal user is someone who's running on a corporate network, right? So my public IP is considered an approved IP that I can reach to the firewall in order to jump into the box for SSH, or if I want to reach the Istio, I can do that, the ingress gateway, and test all my applications there. However, for that case, I'm also allowing any other source to reach my applications that are hosted on the AKS cluster. Obviously, that means you can, in certain environments, limit that through the firewall as well, that only specific sources can reach that ingress. I am utilizing Azure Container Registry as a premium, the premium tier of it specifically, so I can enable the firewall on it, the resource firewall, where I'm only allowing my IP to reach it, as well as the subnet of the Azure Firewall over service endpoints. It might sound a bit outdated, the fact that I'm not using private link or private endpoints from Microsoft Azure. The reason I still till now do not prefer to use them, because first of all, in the case of AKS clusters, they do not support uptime SLA. So in my honest opinion, if there's no SLA, that's not production ready. Additionally, when it comes to the private endpoints, the moment you add a private endpoint in your VNet or any other VNet that is paired with other networks, with your express route also to on-prem, that makes it available to anything. You cannot add NSGs. You have to have an MVA where everything is routed through it and control everything through outbound NSGs and outbound rules on your firewalls. That is not feasible, especially at scale. So hopefully Microsoft engineering can work around that limitation and make it feasible to use private endpoints in a more realistic way, to be honest. Additionally, one nice feature, at least when it comes to the AKS, even if I don't deploy it with a private endpoint, I would be leveraging the API authorized IPs feature on the AKS control plane. You can enable that, and in this case, I'm only allowing the firewall public IP, because all my nodes in the cluster are going to be routed through my firewall, and my firewall's IP is allowed through the authorized IP list on my AKS control plane endpoint. That allows it to communicate. That allows the communication between the nodes and the kubelet there with the AKS control plane. Additionally, I'm allowing my own IP, and I have a bunch of test cases to show that this is functioning as required. In addition to that, the AD authentication is enabled on every cluster. That is a best practice and a recommendation to be enabled on every cluster. That's pretty much the high-level overview of the architecture. There's a good reference here to follow, so I use some color coding. It's a bit difficult to add some numbering or ordering for this because it involves multiple flows of traffic. So I use some color coding to showcase that. So anything that's in goldish color is more of public traffic technically, but it's only from internal sources or authorized sources between quotes. So someone who's on the corporate VPN would be represented by that, as well as the dark red color is more of a public external source, so any source from the internet. And as you can tell on the control plane, they're not going to be able to reach it because of the API authorized IPs being enabled. And for the ACR, because I have resource firewall enabled, it will also not be able to reach it. However, if it flows into to my STO, it flows through the Azure Firewall. And I will show the ability on the diagnostic settings and logs and Azure Monitor that you can see each and every packet that's passing through, and all the information will be there. So I've allowed that to continue to function normally. And when it comes to the SSH access, it's only allowed from the internal user. The internet will not be allowed to reach this jump box. And I will also test that and showcase. And the last part is, as you can tell, anything green is more of an internal traffic. You can control that with NSGs, ASGs, firewall as well. Obviously, will be part of that because everything is routed through it. Does anyone have any questions about the architecture before I proceed? Okay, I'll go ahead and proceed. So, and as I mentioned, there is in the repo, there is a single script. Yeah, it's around 500 lines of bash. All you have to do is just run that script. It will deploy this in your subscription. As long as your subscription has all the resource providers enabled that are required, and you have enough credits. It's a bit expensive to run this environment. I'd say it's around $8 to $10 an hour. So be careful. Don't forget your resources. Make sure you delete them afterwards. So just at a high level, a bit about the Azure Firewall features. It's highly available, it's scalable. All that the high availability and the scaling are built in. You don't really need to do anything. You don't need to add load balancers or any other resources like you would do with any other MVA like FortiGates or anything else. It's backed by an SLA of 99.99%. If you're using AZs, if you're not using AZs, it's 0.95%, I believe so. It gives you the ability to centralize all your layer 3 to layer 7 traffic filtering. So you might ask, why wouldn't I use just NSGs? NSGs are not sufficient, although they have, for example, support for service tags that are Azure IP addresses. However, you find yourself always needing layer 7 filtering using FQDNs and wildcards. You cannot always keep track of IP addresses, and not everything is on Azure. You might be reaching other sources for sure. So Azure Firewall works on the layer 3 up to layer 7 in the OSI model, so it allows you to have a lot of control over that the traffic. Additionally, it still supports service tags similar to NSGs. So I can put Azure Cloud.Canada Central. It will automatically allow everything in Canada Central. It supports FQDN tags as well. So these are unique to Azure Firewall. I think it has tags like Windows Update. It has tags. One of the tags that are actually used by the script is for Azure Kubernetes Service, because there is I'd say around 7 or 8 different FQDNs that need to be allowed in the application rules for the Azure Firewall. So your AKS cluster is able to communicate with everything it needs on the Azure side. For example, like MCR, the Microsoft Container Registry, to pull all the images from there that run in Kube system and so on. It needs to communicate to certain also blob storage endpoints and so on. All of that is under one tag. So Microsoft has made it very easy for you to configure that. If you go to another MVA that's third party, you have to trace all of these FQDNs and add them and keep up to date. So when it comes to the tags, whether it's service tags or FQDN tags, Microsoft will automatically update them whenever any change comes in. Additionally, it has built-in support for Microsoft Threat Intelligence, so it can detect. By default, it's set to detect any malicious traffic, but you can set it to even block any malicious traffic, both in inbound and outbound, by the way. Additionally, as you saw, it supports both source netting and destination netting. It's very helpful and flexible to utilize your firewall to do all of that. Additionally, it supports multiple public IPs, so you can have up to 250 IPs. That's more than enough, to be honest with you, with the number of ports that are available for you. If you can build a lot of mappings when it comes to destination net or source net. However, you need to also be careful on the source netting port exhaustion that could happen. So that's also available through Azure Monitor. So everything is logged there, logged through Azure Monitor. So you'll be able to monitor all of these metrics on your firewall, as well as all the rules and everything that's matched. So the script also that I've provided does deploy that. It enables the logs and sends them to Log Analytics, and it also deploys a sample workbook available from Microsoft Azure that will actually build a few graphs and tables that showcase the rules and what's happening, and I will show that during the presentation. So when it comes to AKS Network Security at a high level, as the architecture already showed, but just to list a few points, always make sure you deploy your cluster into your own VNet and subnet. If you let it up to Microsoft, they will deploy a VNet, but you have no control over it. That's not great, especially in big enterprises and locations where security is very important. I would say deploy fully private clusters wherever possible, if you don't care about the uptime SLA, or at least protect your AKS API endpoint with the IP whitelisting. It could make things a bit of a hassle, but if you have a firewall or you have NAT gateways enabled or any other ability to control your outbound public IPs, and you should always have that for sure, you would be able to add the IP whitelisting rules required on your AKS cluster API endpoints, so you can still manage it as needed. Additionally, make sure you always leverage Kubernetes network policies. Or Calico ones. So I personally prefer to use the Calico network policies, not the Azure CNI ones. The Azure CNI ones have a lot of issues, and there have been a lot of complaints about them. Even if it's supported by Microsoft officially, it doesn't work that well. So Calico would be a better network plugin to enable. And if you go to an enterprise level, you can also integrate Calico Enterprise, which is a great solution. I've personally worked on it a bit. It's pretty nice to centralize all your policies within your Kubernetes cluster in one location for multiple clusters, multiple namespaces, and so on. So that's something that would be great to always make sure you have isolation between your namespaces using your network policies, and even within the same namespace, similar to how you do microsegmentation in a typical old style network of virtual machines, where you have a front end and an application layer and a DB layer. Only your application will speak to the DB, and the front end speaks to the application, but never to the DB directly, for example. So you would be able to mimic all of that with Kubernetes network policies. An additional recommendation is to deploy a service mesh solution in your cluster. It still has its issues, but it works, and when it works really well. It's very chatty, but they're working on enhancing that. It's very quick in terms of updates. And the example that I've provided, I'm just going with 1.4.10 as a version. You can consider updating to other versions. All you have to do is just change the version that's being downloaded. It should work out of the box. I don't see any issues or anything stopping it from working at a newer version. It's just that I left it at 1.4.10 because it still had multiple components in place, and I wanted to troubleshoot if anything tries to communicate to the control plane, and if it's failing or so on, while I was integrating the Azure Firewall in place. In addition, make sure your ingress controller. I see this happen as always a mistake that comes up, where people will just deploy the ingress controller template as it is out of the box. By default, on cloud providers, including Azure, that's gonna create a load balancer service of a public load balancer service type. So it's not going to create an internal load balancer for you. Make sure you update your template to always deploy the ingress controller as a private one, and then you can put in front of it either you go with a firewall or a WAF with an app gateway. So you need to expose something that is secure. You don't expose a load balancer directly with all your ingress endpoints there, and you can leverage the TLS termination there. And then within your cluster, if you have something like Istio in place, you have MTLS or mutual TLS running within your cluster. And I will also showcase that and how it actually works really well and would block any man-in-the-middle attacks or anything that could happen within the cluster. Let's say someone adds a pod, but it's not part of the mesh, they will not be able to communicate with the other parts of the service mesh. And you can leverage, ingress controllers features, whether it's the Istio ingress controller or anything else, to set a minimum TLS version 1.2, because that should be a standard, even 1.3, but 1.3 adoption is taking time. For now, 1.2 should be a bare minimum in place. And obviously, that's something lacking in the architecture I've put. But at a bigger scale, you can add a WAF like App Gateway or integrate with Akamai for to protect your public endpoints. When it comes to the AKS Active Directory integration, so the way it works is now it's become pretty straightforward. There is a version 2 that has been released a few months ago. The initial version 1 integration was a bit overly complicated. You had to set up multiple service principals, one as a client app in your AD tenant and the other as a server, and you have to set them up to communicate and provide them for your AKS cluster deployment and so on. Now it's pretty straightforward and just managed by Azure on your behalf, but you have to just provide your tenant in the deployment, your tenant ID, and it pretty much integrates your AKS with your tenant for authentication. So the way it works, the flow is pretty straightforward. The user would authenticate first with Azure Active Directory. They retrieve their token, their access token. And then if they have obviously access at the Azure level to the cluster, they can fetch the kubeconfig from the cluster by running az AKS get credentials. That's sample command. I go mostly with bash shell, so I just use Azure CLI. I believe there is a PowerShell option to do that, but I mostly stick to Azure CLI. So the Azure CLI command to do that is just az AKS get credentials, and then the resource group name, the cluster name, and it will pick up that credential and that kubeconfig. However, that doesn't mean you have been authorized to use the cluster. That's sometimes also that could be confusing. But then when you perform your first action on the cluster, like kubectl get nodes, for example, AKS will do what it needs to do and validate with Active Directory. It will determine your group membership, right, or the your direct object ID of that user, plus the group membership. And then after it fetches that group membership of that specific user, it will match it to the internal Kubernetes RBAC policies. If you are if that internal RBAC policies, the role bindings or the cluster role bindings allow you to do the activity that you have or the action that you have attempted to do, you will, it will go through and it will be accepted based on your permission, and you will be able to retrieve the information or create what you need to create and so on. If not, it will just be rejected, and that's how it was. And I will showcase two examples, one of an AKS admin group, and the other is of an AKS readers group, and you can see the details. So one thing to mention is that there is now a preview feature that you can use Azure AD RBAC for authorization in AKS. So they have added that into the Azure RBAC using data actions, similar to how you have data actions on storage accounts and so on. They have added the data actions to that are Kubernetes related. It's still in preview though, and you have to sign up for it. So I prefer not to use anything in preview till it's in GA, because usually they try to they end up changing a lot of things, so it's preferable to wait for GA. But that's a nice feature that's coming up. It will be really helpful. especially if you want to use any service principals for automation or so on, instead of using service accounts within your cluster. That would be helpful, because currently the only way to do automation with a service principal is to give it full cluster admin. You cannot give it specific access within the cluster, so it's a bit of a hassle. So next up is Kubernetes network policies. So at a high level, it works only at layer 3 and 4, so it will not have very advanced policies. They would not have any effect unless you have a network plugin in place, like Calico, or the Azure CNI network plugin enabled for the policies. Additionally, it includes two types of policies, either ingress or egress. In all honesty, I've always avoided egress unless I want to block full egress from a specific namespace. For one main reason is that egress is tough to handle with only layer 3 and layer 4. And this is where the beauty of using Azure Firewall comes in, because egress is more to control the outbound traffic of where you want your pods or your application to reach. If everything is routed eventually through Azure Firewall, it doesn't matter. I can control my egress there at a place where I have much more advanced functionality and ability to manage it at layer 7. And I don't have to worry about finding the IPs and so on. So it's not really very essential to set up egress policies unless you want to control things within the namespaces themselves. So let's say this is a namespace that has a DB, and I want it to have no internet access at all. I don't care about that. It just needs to reach a specific other namespace or other pod within your cluster. So it uses, again, that typical way of doing things in Kubernetes is selectors, and this is the standard they've followed in the technology, is to use selectors. And in the case of network policies, you use a pod selector to group your pods based on the labels in them. If you give an empty pod selector, it will just choose all the pods in the namespace where you're applying that policy. Additionally, you can also combine, you can add a namespace selector or use a namespace selector to specify a namespace instead of pod selector. And it will also be based on the labels, so you have to label your namespace. This is an example diagram of, and it comes from this source. It's a great network policy recipes repo, to be honest. You will have a lot of examples there that you can start with and build on top based on your use case. In this example, for the namespace, the default namespace is only allowing traffic within the namespace, nothing from any other namespace. Everything will be blocked, and that could be easily built with policies, with other policies. You can also. It's important to note that you can use a combination of these selectors. So I can add a selector that I'm only allowing, for example, default namespace and plus the app equal DB selector. If I have something else in the namespace that has a different label, it will not be allowed to communicate to this. So it's very flexible. But at the same time, it lacks the flexibility of additional layers above layer 4. You can use IP block to also select particular CIDRs. Again, it's very difficult to maintain. If you have a use case where you don't care about the namespace or the pod being fully isolated, you can utilize something like that and then allow only specific IPs if you're using that. Of course, since layer 3 to layer 4, you can also specify a port and a protocol for these rules. I've added 2 resources here in the presentation that are really, really good. As I mentioned, this is a repo that has a lot of good starter network policies. And the other one is from Tufin, actually. It's a network policy viewer. And I'll be honest, even if you use, personally, I don't know, maybe someone else would be better at this, but even if you use network policies for 2-3 years or whatever, it's always good to have a visualizer for it because it's very tricky. And for example, if you give pod selector as a part of an array and the name selector as an array, they will consider it as an OR, not an AND. And if you put them, so if you remove that hyphen in the YAML, it makes a big difference. So it's always nice to use something like this viewer. It's very helpful. So you can put your YAML there and visualize your policy. It's not going to build a diagram like this, but it's just going to give you a table with what has been selected and what is the destination and the source and so on. It's really helpful. So it would be nice to use that. Some additional AKS security, and I'm not covering in this one, but it's things to keep in mind, and maybe they can be covered in the future. One best practice I would recommend is to physically and logically isolate your clusters. So by physically, I mean to have totally different clusters for production and non-production, even for lab as well. So it's much better to do that first of all, and there is no harm in that. I know it's additional, maybe from an operations perspective, it's an additional headache to manage, but it's worth it because you are fully isolating everything. And technically or typically, maybe in a smaller scale it wouldn't be like that, but in a bigger scale and bigger enterprise, your network in non-production should be isolated from production in general. So you wouldn't deploy a non-production cluster and then use that even for a production namespace. You should not do that. So you would logically, physically isolate them that way. And the good thing about Azure and AKS is that you don't really pay much. The uptime SLA is like 80 Canadian dollars or something, 90 or so a month. It's very minimal for that uptime SLA on the management endpoint. Otherwise, you don't pay anything for masters, unlike other clouds. You don't pay. So it's really helpful to utilize the ability to physically isolate them. So you'll have totally different endpoints. You'll allow, and since if you have AD integration in place, you will allow different AD groups to have access to different endpoints. You will allow even different sources on the IP allow list if you want. Right? When it comes to logically isolating, that's about having different namespaces and adding network policies between them. Or if you have a service mesh like Istio running, you can add even authorization policies in place on top of your network policies to isolate your namespaces fully and even within your pods internally. Another helpful feature in Azure is Azure Security Center for AKS. It will give you really great recommendations, such as let's say your AKS version, a compromise, some compromise comes out or some security issue comes out, and it's out of date and they're not going to support it as it is. You need to upgrade it. That's a day 2 part of AKS or any Kubernetes, to be honest. It's not, they want to call it PaaS. It's not really a PaaS service, in my honest opinion. It's more of a K as a service. It's like Kubernetes as a service. So keep that in mind. Everything that's related to Kubernetes will always apply to it, and doing these upgrades are up to you. They're not going to force you to upgrade your version or update it. So you will get that recommendation. Maybe it slips, especially at a bigger scale, it slips your mind, or you might, your day 2 operation team might not notice. So Security Center will always give these flags that while your version is now out of date or support, you need to update it. And obviously from Security Center, you always have that runtime threat protection against any malicious activity. An example, if you have AKS integrated with Security Center, you will, let's say someone goes into the cluster and creates a service account and gives it cluster admin, which is a bad practice, or gives it access to secrets. It will show up on Azure Security. An alert will show up that this is activity. Why did you give this much permission? It's too much permission. Something is going on, or validate what's happening. Right. So that's great, even for security teams, to keep an eye on the clusters. One amazing feature, to be honest, in AKS, I would like to cover it someday, but it has a lot and it keeps growing now, is Azure policy for AKS. It actually just went into GA and Ignite, but I've been using it since day 1 of preview, to be honest. It's an amazing feature. It works really well. Azure and Microsoft have been a big contributor to the Gatekeeper project, the Open Policy Agent, and they have built Azure policy around that for AKS. So Gatekeeper is an open policy agent, is an open source tool that you can add to your cluster. It's like an admission controller that allows you to add policies, and it has a special Rego language to define policies in your cluster. For any open source, any Kubernetes cluster, it can be used. But in the case of Azure, they have chosen to wrap it up with Azure policy. Then you have that one single pane of glass to view everything, and under the same whole Azure policy setup and Security Center and their compliance level can be viewed in one location. And the policies include things like, for example, your containers can never run as non-root. Your containers should run as certain UID and GID, or a certain range is allowed. They have to be non-privileged. So they have actually recently translated a lot of pod security policies into Azure policy for AKS, and it's really great. It works really well. One great policy is, let's say you give some developer or someone who just want to get their application deployed and get it up and running quickly. They might go ahead and deploy the ingress as it is, right, without stating that I want an internal load balancer, and then it's exposed publicly suddenly, right? And that's not great. So you can add a policy that would only allow load balancer service type of internal load balancer. That's a really great policy, and it works really well. So it helps you achieve that kind of security in your cluster, and it's all monitored in one location. And apart from security, it also helps you, achieve a good state of governance. You can enforce policies where you have to enforce labels. Everyone has to put labels on their deployments and their pods and so on. You can enforce CPU and memory usage. Like everyone, you cannot deploy anything without setting at least the CPU and memory usage on it, or else things go crazy, especially in multi-tenant cluster. So it's really nice. It has a lot of features. So I would, if you haven't used it, I really recommend you look into it. It's great. It might cause some trouble when it comes to fixing your templates if you haven't taken all of this into consideration, but it works great. It's really important for securing the cluster. One more thing I would recommend is to enable diagnostic logs, especially Kube audit logs. Kube audit, and now they have Kube audit admin, so that's more of create, delete, and update activities, while Kube audit has become more for the list and get and so on. So you can choose to enable both, or in production, for example, while in non-prod, I only care about the create and delete and so on. You can enable that as well. You will see each and every activity, every service account, every user from Active Directory. You will see their ID, everything, the reason why they were approved. It will tell you they have this cluster role binding or this role binding, and that has allowed them to do this activity. It's very verbose, it's very helpful, and you can build all the alerts around it. You can trace every activity in Kube system, for example. No one can touch that. Let's say you deployed Istio, you will trace every activity in Istio system. No one can change Istio's auto MTLS policy, for example, and so on. It's extremely helpful. And from a security perspective and audit trail and compliance, it's very helpful as well, or very essential actually. One more thing is to install the QRAD agent. So QRAD is Kubernetes reboot daemon. So it's an agent that will, Microsoft, again, that's where it's not a pass, right? It's not really a pass, because it's not like I don't care about the infrastructure running. I don't manage the image, I don't manage the VM, it's self-healing and so on, but I still have to do some work, right? If I want to upgrade the version of Kubernetes in general, I have to do it. If I want to add nodes, I have to do, and so on, or I enable autoscaler, for example. So you still have some responsibility or control over the infrastructure that's running. One of these is the patching. So the patching, not the actual patching, but applying any security patch, right? Indirectly applying it between quotes, because it requires a reboot. So the patching will happen automatically by Azure. It's managed by them, happens from their backend. You don't have to do anything, which is great. But if a patch requires a reboot, if a patch is for the kernel that's running, or any security patch, or anything else that is in the cluster, or any module or anything that's running that needs a reboot, you have to do that. How will you trace that? You can add your own, obviously, custom way of looking at the Sentinel file that gets created in the Ubuntu node, but you wouldn't do that. You would want something automatic in place. QRAD agent is great. It's the solution for that. Everyone uses it. You can deploy it and give it a schedule that I want it to run certain days of the week. For example, if you have two environments, you would put it in an alternating way, right? Like my first production environment, my main one is, let's say, Monday, Wednesday, Friday, while the other one is Tuesday, Thursday, and Saturday, and so on. And I would leave one day off, for example, without any reboots happening. Or you could leave the weekend without any reboots and do possible reboots on the others, right? So the agent runs in a privileged way. It has to be privileged because it has to access the host node. It runs as a daemon set. It will run one agent per node. Obviously, that's how daemon sets work. And it will continuously check, or you can even give it a time window. Either you can set it to 24 hours, or you can ask it, okay, between 2 a.m. and 4 a.m., please check the nodes. And if anything needs to reboot, go ahead and do it. Right? So when it's deployed, it gives itself you add the cluster role and so on, everything. You can deploy it through Helm, or you can take a templates available on the repo to deploy it. It does everything needed for that deployment, but you can customize the schedule, the days, the time. You can add a Slack channel or a Teams. The same, it's called Slack webhook, but it also takes a Teams webhook. You can add, in the case of Slack, you can alter the username that will be used for that webhook. It will trigger the webhook and let you know that there is a reboot coming up, that this node needs a reboot with a node name, and you can give it a name of which cluster it's running on, so you can identify that. Because if, let's say, you start getting alerts or something, you're looking at the pods, if they get evicted or so on, you would know that, well, you can match it with the trace in your Teams channel or Slack, that, okay, well, it's the QRAD agent doing what it needs to do, right? So there's no need to freak out. It's just evicting. So once it detects that, it evicts the pods, and once all the pods are evicted, it will reboot the node. Once it comes back up, it will do the other one in case the schedule still allows. It will only do one at a time. It locks things down. It doesn't do multiple nodes at a time. So if, let's say, one node is stuck in the reboot, it will not bring down your whole cluster. So it's really safe. It works really well, and it's a great solution. Two things to note about it is make sure you take into consideration the fact that you should be running multiple pods, because if it evicts one, if you're only running one replica, you're pretty much that microservice is down. So keep that in mind. It doesn't care about that. But one thing it cares, or it's forced to look at, is the pod disruption budgets. So keep that in mind. If you have a pod disruption budget in place, that I need to have one pod at least running of something, and I only have one pod of it running, QRAD will be blocked. It will not be able to do the work. So if it comes to evict that, and there's a pod disruption policy, that takes precedence, and it will not be able to evict the pod from the node, and technically not be able to reboot it. However, your node will be set to not ready for that time, and it's going to be damaging to your application, how it's running, because of one pod or two pods that are running in there under a pod disruption budget. So keep that in mind. So last recommendation, which I'm sure everyone knows in the enterprise DevOps group, is don't do any direct deployments for sure. Always use a CI/CD pipeline like Azure DevOps or GitHub Actions, and I'll leave that to the expert like Max and so on. So that's for sure something to always keep in mind. When it comes to container security, some best practices is to always obviously patch and update your container images. Always use a Yeah, sorry, go ahead.
So the CI/CD solutions, there's a number of the Kubernetes native solutions of CI/CD. I mean, in addition to Azure pipelines or GitHub, right? Anything you can recommend?
Nothing specific, because I mean, it's about the toolset, right? Whatever toolset you use, whether you're using Helm or Customize or anything, you can run it on Azure DevOps as well, right? You need a pipeline to run it, whether you run it on Jenkins or Azure DevOps or CloudBees or whatever, it's going to be the same, right? So there is no specific recommendation. I'll remain neutral on that. Yeah. So yeah, from a container security perspective, and this is the typical thing, but always patch and update your container images. If it's running, it's running. I understand that, but it's not always running securely. So hackers are always ahead, and vulnerabilities always come up. So make sure you're patching your image regularly. Obviously, always use a secure and a private registry. If you want to utilize ACR, what I'm showing in the architecture is an option of how you can run ACR, or you can run it with a private endpoint if you're comfortable with it not having an MSG. Or if you can use Artifactory or anything hosted as privately, you can even host it on-prem and over express route your cluster. That's the advantage of deploying your cluster inside a subnet. Your cluster will be able to reach that on-prem through express route, the on-prem registry. If you're using ACR, it's great to enable Azure Security Center for ACR. And because actually now Azure Security Center has a feature of Qualys scans that can run on your images. So built in, I think it's even free of charge, except for like, whatever you pay for ACR. So it's a great feature to leverage, and it pretty much covers the main one about patching and updating, because it will always bring up any issues in your images. And in addition, in ACR you can also enable ACR content trust. So content trust is pretty much the idea that a set of cryptographic signing keys will be associated with your ACR, and they can be used for image signing. So whomever is publishing that image would sign it and then push it to the container registry. And I think it can all be controlled through AD, and there is a special Active Directory RBAC that can be given to permission that can be given to be able to do this, and all the images will be signed and stored in Azure Container Registry. And whenever a consumer wants to pull that image, they will pull that signed image, and their client will verify the integrity of that image. I think the last thing is everything that's related to Kubernetes from a best practices will always apply. So think of it as Kubernetes as a service. Don't think of it as a PaaS. So you need to apply anything that you would do on any Kubernetes cluster to a certain extent. So whether it's like how you handle namespaces, your request limits, least privilege RBAC, all of that should be handled properly. So I'll switch now from the boring stuff to a bit more interesting. Just give me a second. So this is the script. I'll go through it quickly. It's pretty long, but it does what it needs to do. You can simply just, if you want to change all the names, you just change that name prefix and it will deploy everything. I've set it to Canada Central. You can choose another location, but I know it works in Canada Central. I think Canada East would not work because this deploys a log analytics workspace. It's not supported in East. I'm not sure about other regions. I generally focus on the Canadian regions. I avoid deploying elsewhere. Resource groups. The resource group name will be created. It will create two resource groups actually, one for all the resources that are related to the network, and one for the rest of the resources, which is the AKS cluster and the ACR and the log analytics workspace and so on. I have a bunch of things hard-coded. You can feel free to change it, but
can you go back?
Yeah.
Line 6 and 5.
Yes. Sorry. Yeah, tell me. What about line 6 and 5?
Explain. You call them.
Oh yeah, yeah. So this is in Bash 4. How we make. So this is in case someone comes and does this. I just make sure it's all lowercase. So this changes a variable to lowercase. So I'll just give you an example here in Bash. Yeah. And then if I do this, because I believe it might cause some issues, especially in the ACR, because I think it has to be a DNS name. So as you can tell, it changes it into all lowercase. So that's why I've just put it in one place. Okay, and just the first section is all setting a bunch of variables. This is an array of all the images that are required by the demo. So these are all Istio images that are needed. I have a loop that goes over all of these and imports them into my ACR. You need to keep it as premium because otherwise you cannot enable firewall on the ACR. It's a few dollars a day, I think like $2 or $3 a day if you set it at premium. And this is the array of images. I'm also pulling the Nginx, one of the Nginx images for some testing and a bunch of for the testing purposes and the demo. I've used the OFO application from Istio. I'm also pulling these images, and I'm deploying Istio, and I will go through the profile that I've been using for the Istio operator. The network plugin, I'm using Azure network plugin, so it's the Azure CNI. However, if you want to change it to KubeNet, you have to do some changes that will not work. This script will not work with KubeNet because in the case of KubeNet, it deploys a UDR of its own that's managed by AKS. So what you would need to do is actually create that UDR first, give the AKS service principal access to that route table, and then do the deployment with kubenet and reference that it will automatically pick up that route table and use it. So your route table that you will provide will have you will add to it the routes to the firewall, and Azure from its end, or AKS, will automatically add all its routes that are needed for kubenet to work. I kept it at Azure CNI. It's pretty straightforward, so there is no need to use kubenet for this demo. But I still enable Calico, so I can use it for the network policies. For the name, it's all the names depend on the prefix. Again, I do the same thing of making it lowercase. The node size is set to I would recommend to keep it at least 4 cores and 14 to 16 RAM gigs of RAM per node. I'm deploying 3 to 5 with autoscaler enabled. OS disk I'm setting to 256. Everything can be changed, obviously. Docker bridge CIDR I'm setting it to 172.17.01. The service CIDR is this, and for the DNS service IP, I just pick up the service CIDR and I just cut it up and set it to .10. So it's going to be 10.240.0.10. That's going to always be the DNS service IP. So instead of making 2 variables, you just set here. If I change this to 250, it's just going to pick it up and use the 10. I have 2. This is a prerequisite that needs to be already created, which are 2 groups in Active Directory, in Azure Active Directory. I have one that's called AKS admins, and I have one that's called AKS readers. One thing to note, and this is one of the reasons I didn't run it through Azure DevOps or so on, or any other automation tool, is if I'm going to use a service principal, by default, service principals in Azure do not have access to Azure AD users. You need to grant them that permission. You need the consent of the global admin to allow the service principals to read from Azure Graph or Azure AD. So this script will only run if you run it as a user. Obviously, if you create a service principal that has access to Azure, this will work. Or you can set these as values here. Instead of names, you can just give it the object ID, because in the link between Active Directory, Azure Active Directory, and Kubernetes RBAC, you need to use object IDs. It doesn't work by names. So that's essential. This is a small piece also to pick up the latest version of Kubernetes available in the location. So the latest one that is not preview. So I'm excluding preview. It just picks up the latest one. I think currently it's in Canada Central is 1.18.8. And then for Istio, I'm deploying it with the Grafana and Kiali enabled and so on. So for Kiali and Grafana to start up, actually, after you deploy Istio, you need to create secrets for these. So what I'm doing, I'm just setting a few variables for a Grafana username and a password. The password, I'm just creating it from 16 random characters pretty much, and same for Kiali. Then there's all these variables for the network, the resource group, the VNet name, the CIDR of the network, the subnet name for AKS, this is pretty much the usable hosts here. I think like 64,000, or I think no, this is 8,000 something. The total is nearly 64,000. And then there's a Jumpbox subnet, Azure Firewall subnet, obviously. Azure Firewall subnet needs to be /26. Okay, so that's the maximum. You can make it a bit smaller, but I just kept it at /26. So this is in case it needs to be scale up or so on. It needs this size as a maximum for maximum scalability. For the Azure Firewall subnet, please make sure you do not change that. It's a requirement from Azure to have this exact name. It needs to be called Azure Firewall subnet with this casing, I guess, as well. There's going to be a firewall, private public IP, for the firewall. It will be part of the IP config for it, the route table name, the route name in there, the route to internet. I will explain this one. There is a bit of a trick to do if you're going to use a public load balancer. In our case, it's not needed. But if it's going to be used, you would want to do that. And then the firewall name, again, it's all variables. And for the Jumpbox, I'm just using a CentOS 8.2 and a small machine, just 2 cores. And the namings for it, and I'm using JB user as the admin for it, and I have the command to generate the SSH key at creation time. I guess a lot of these are pretty straightforward. I know, Max, or if anyone wants me to go through them, I can continue, but I think you can feel free to go through it and comment on the repo or anything you need if you have any questions. But pretty much it creates everything I just mentioned. And it's all ordered, and you have all the output in place. I start with creating the network, obviously. This gets all the service endpoints available, and just out from the start, I have them enabled on the firewall. So it's a Microsoft recommendation. Since everything is routed through your firewall, if you want to do anything through service endpoints to allow you access of your resources to your Azure storage or Key Vault or so on, you will enable firewall, let's say, on the Key Vault or on the storage. You would want to allow your subnets. So in this case, all you need to do is only allow the firewall subnet, and everything gets routed. And that's what I'm doing. So I'm allowing all the service endpoints, and it doesn't cause any harm, to be honest. I've actually even discussed this with Microsoft Network Engineering. There is no harm in enabling the service endpoints on all your subnets, and they will only be needed when you want to allow something through the firewall. Right? So it's better to do it from the start, because when you allow it through the firewall, and if it's not enabled, and you have to enable it, let's say something is in production, it might cause some minimal outages or it might break the TCP connections and so on to reestablish them. So it creates an NSG on the subnet, on the AKS subnet, and NSG on the Jumpbox subnet as well. You cannot add an NSG to the firewall subnet, and you don't need it. It's a firewall, right? So you don't need to add an NSG to it. And it's not supported because it would block its connectivity to the Azure backend. And then this continues to create all the networking pieces, the Azure Firewall public IP. There's a CLI extension in Azure CLI for Azure Firewall. It creates the firewall. It takes time. That's one of the reasons I'm not running it. The firewall creation takes time. Adding the rules to it takes time as well. Then creates an IP config for it with the public IP attached. And then I keep track of the public IP and the private IP because I will need them for the rules. For example, I need to allow the public IP in the API endpoint on the AKS cluster. Then it creates the route table. It adds to it the routes, so everything will be routed through the firewall. And there is a piece here, and I put the link to the Microsoft explanation. There is an issue that could happen with the asymmetric routing. So this is the fix for it. It's a bit of a weird fix, but it's what recommended by Microsoft. So what could happen if, let's say, you have a public load balancer as the ingress to your AKS, or you have a public load balancer in general, and you have a bunch of workloads behind it. If you route them through the firewall is stateful. So let's say you send a request through the public load balancer. You're okay with that. You don't want to send it through the firewall. So you send it through the load balancer. It will come to your workloads. Your workloads are configured to route back through the firewall. When the firewall gets that, it's pretty much getting half of the session. It's not getting the full session. It will drop it because it's stateful. So it will not accept it. It will directly drop it. And this causes what is known as an asymmetric routing issue. So what you would do is add this specific route that pretty much routes the public IP to the internet. So it says if anything needs to go to the public IP of the load balancer, take it to the internet. It fixes things on the Azure backend apparently, but this is a recommendation. And it fixes your problem. So you can still hit that public IP, but it goes, in addition to that, also you create a DNAT rule from the firewall public IP to the load balancer's public IP as well. So you'll end up hitting the firewall public IP, and that will route to the load balancer public IP, and then from there go to the workloads, and then come back to the firewall's public IP with this routing, and it fixes the issue. But in our case, it doesn't apply because again we made it an internal load balancer. But if you ever have that use case, keep that in mind, and if you want to use Azure Firewall, this is gonna be something you will face, or even another MVA like FortiGate or so on. Again, this attaches the route table to the AKS subnet, to the Jumpbox subnet. This retrieves my current public IP to use it also in the remaining commands. I get also the IDs of the subnets. They're helpful or needed, actually not helpful. Then the Active Directory tenant ID and the subscription ID as well. And then it start creating all the demo resource group, or where your resources will exist. I start with creating the log analytics workspace, the ACR, The dedicated data endpoint on the ACR, I enable that because we will need that in the firewall application rules. So your AKS cluster is able to reach the ACR. Additionally, I allow my public IP through the ACR. I allow the Azure Firewall subnet through the ACR resource firewall. And then I start adding some rules to the firewall. So I add an application rule to the firewall that allows the AKS subnet as a source using HTTP, AT, and 443, and HTTPS over 443. So application rules in firewall only accept HTTP, HTTPS rules to FQDNs, and FQDNs could be wildcard as well, could include wildcards. And additionally, I think they have added support for MS SQL on, I think, 1443 or something the port is, but it doesn't support anything else. So keep that in mind. You cannot add an application rule with, let's say, TCP 8080 or something like that. It has to be HTTP with a specific port, or HTTPS. It cannot be any other protocol that is running. And then it just mentions that the target FQDNs that I'm giving is a space delimited list, which is the ACR FQDN and the data endpoint of that ACR, and I'm allowing it, I'm giving it a priority. And you can have a priority from 100 up to 65,000, I believe so.
Quick question.
Okay. Yes.
What version of AZ CLI do you need?
Sorry, what?
The earliest version of AZ CLI?
Yeah. So I have that in the README. I'll show that, but I've tested this and I've used it with 2.2.10. As long as, I think even before that it should work, but to be on the safe side, make sure you have Azure CLI 2.10 and above.
Thank you.
Yeah, always. So then the next step is I create a service principal for the AKS cluster, because when you integrate it with a subnet, you need to give that cluster the ability to use that subnet. So you have to create a service principal and attach it to your cluster when you create it. Then I assign that cluster, that service principal, network contributor on the VNet, and then I assign it as well an ACR pull role on the ACR. And then this is the small loop that just goes through all the STU images and imports them into the ACR. Okay, and in the importing, I'm just removing some of the slashes in the names and so on. I'm just keeping them, in a more organized name inside the ACR. And then I start adding all the Azure Firewall rules. This one will create the first rule, as I mentioned, the FQDN tag. So this is one of the main requirements. The FQDN tag needs to be allowed before, and it's better to allow it before you deploy your cluster, because they will keep failing till this rule is allowed. A lot of the pods will not be able to start up. So this rule will allow it to reach all the requirements like MCR and so on, to pull all the images. And there's a lot of things under it. You can find it in the documentation, what this tag implies in details. But it's pretty straightforward and made easy with Azure Firewall. This is all you need to do. And I create the cluster. So in the case of the cluster, all the parameters go in here. Some of the stuff that's hard-coded is the outbound type, as I mentioned. It's user-defined routing. It's not load balancer or so on, or just a default. Because in the load balancer, it will create a public load balancer and use that. We don't want that. We want to define our own routing. I'm enabling the autoscaler. It's a scale set. All the variables go in here. Monitoring is enabled with the workspace that was created. The plugin, all the details are in here. And these are a few important things to note, which is the API server authorized IP range. And in this case, I'm adding the firewall IP as well as my IP. Okay, you can add obviously more. You can have a list of specific ranges. It can be, this is 32, so a single IP could be a cider of IPs. And then you have the service principal ID needs to be provided. The service principal client password should be provided. And I'm asking it to skip the role assignment. So this would help you to run it even if you're only a contributor, not an owner, and someone had given the access to the subnet on your behalf. And this enables Active Directory. And in the case, I just need to give it the object IDs of the admin groups that will be added. And I'm adding the AD admin group. Then I also need to provide the tenant or the Active Directory tenant, the Azure Active Directory tenant, the ID that will be to which it will be attached. And I'm just keeping it less noisy with no output. And here, this is the piece that you want to enable uptime SLA or not. I haven't, because I don't want to pay $90 per cluster whenever I deploy it. So, but this is what all you need to add in case you want to deploy this in a production environment and so on. Okay. Then I retrieve the AKS ID. Azure AKS have done a great job, to be honest. I've noticed recently, I'd say a year ago, this used to take around 15 minutes to be deployed. In the past month or two, it became more of, I think, 5 minutes. It's become very fast. It's really good. The only reason this script is slow is Azure Firewall and the rules. Otherwise, deploying an AKS cluster has become very, very fast, actually. It's really impressive. And then I'm assigning the AD groups some permissions, right? I'm giving them this Azure Kubernetes cluster user role. So this is a built-in role in Azure RBAC that allows them to run the AZ AKS get credentials. That only allows you to do this. That's it. That's all you can do. That's all you can do with this RBAC, as well as read the cluster like as a reader. That's all. So and this is helpful because let's say I want to give someone only some production support. I want to give them only read only, and all I have to do is give them the endpoint or the name of the cluster and the resource group and this role. They can log into it, and I control, as the admin, I control what access they have within it. Right. Additionally, this is the piece that just enables the diagnostics on it. So I'm enabling Kube Audit admin, Guard as well. Guard is maybe not very essential, but this has the logs of the integration with Active Directory. So anything happening with Active Directory, I would see it under these. Okay. And then I'm enabling the diagnostic logs on the Azure Firewall to trace everything: firewall rules, firewall network rules, application rules, DNS proxy, and all the metrics as well being collected. And this deploys a workbook. There's a documentation about it. It's a sample workbook that leverages these diagnostic logs from the firewall and visualizes them in a pretty nice way. I log in as admin. I bypass the AD. You can add this feature if you are a contributor or so on, or you have, there's another role which is Azure Kubernetes Service Cluster Admin role that will allow you to do this. So you can bypass the AD and just directly integrate with or connect to the cluster. I do that just to avoid, usually when you integrate with AD, you have that device login and MFA and in place and so on. This allows me to just become a cluster admin and run a bunch of things on it. So I retrieve the server IP address is a Kubernetes kubectl command that gets the endpoint of the Kubernetes service running inside it. It'll get the public IP of it. And then I start leveraging that for adding a lot of rules. So I need to add a rule that allows the subnet, the AKS subnet, to reach the AKS API server IP. You can avoid this by allowing all of your Azure Cloud IPs in that region. I prefer to go with least privilege, so I'm only allowing it to reach this. Over the 1194 and 9000, these are used for secure tunnel. There's an OpenVPN AKS link pod that is running. It uses these two. It uses this over UDP and port 9000 over TCP. As well as HTTPS is needed to this IP address, especially if you have workloads like Istio running. Istio needs to always talk to the Kubernetes API, and it would need to be able to reach it over the IP address because it translates it from this internal service. Then there's a rule that would allow it to reach Azure Monitor. There's a rule that allows it to reach the Ubuntu nodes to actually get the NTP updates that are needed for them to behave normally. One thing to notice, if you see here, there's a network rule, but it's actually using an FQDN. So this is a preview feature from Azure Firewall to use FQDNs in network rules as well. But it doesn't support wildcards. So hopefully soon we will be able to use FQDNs for any type of protocol and port, but at the moment it's mainly HTTP, HTTPS, and MS SQL. These are a bunch of rules that allow access also for Azure Monitor. These are the application rules. Previously it was a network rule, so there's a network rule for Monitor and an application rule. They're all documented in Microsoft documentation. And the last piece is for any security patches and updates and so on, you need to allow these FQDNs in an application rule so the nodes can reach it. In case you don't want to use an ACR, you can avoid this whole piece, and you can uncomment this one. It will allow reachability to Docker and Quay registry and so on, and it will allow you to deploy Istio directly from there. And if you need to add other features like DevOps or even policy, I haven't enabled here, but if you want to enable that, you have to allow some more rules and application rules so it can function normally. So this piece creates, now after the cluster is ready and the rules are in place, you can deploy what you need to it. So this will create the Istio namespace, the Istio system namespace. Excuse me, and then this creates the Kubernetes secrets for the Grafana and for the Kiali credentials. This just a one-liner that would download the Istio package and deploy it. Obviously, you can deploy Istio with Helm, but I'm just going with the operator. So this will download it and extract the zip file and so on, and it just uses istio.ctl with a manifest, which is this profile. And I'm setting the hub to use my ACR. Okay, so I'm telling it to go to my ACR and this specific namespace under it to pick up all the images for Istio. And I'm just cleaning up the Istio package. So if you run the script, you don't need to worry that anything will be left over. Few things that remain out unpatched, or when you run this manifest with this hub, is the fact that Kiali, Source, and Grafana, and Jagger, and Prometheus, I just run a few commands to patch it and replace it in place. The image source, I just change it to my ACR image using some JQ stuff and kubectl replace. So to make sure that they will be able to work. Otherwise, they will just remain in a failed state because it will not be able to pull the image. The cluster has no access to any other container registry. And the last piece is afterwards. There's the piece of adding the DNAT rule for the firewall to the Istio Ingress private load balancer. Right. So after Istio is deployed, I just have a small loop that keeps waiting till the Istio load balancer endpoint is available. Once it's available, it will add that NAT rule. So I'm pretty much allowing any source, and I'm creating a DNAT rule with specific priority, and I'm mapping to port 80 to the translated address, which is the Ingress load balancer IP, which is a private IP. I'm just simply mapping the public IP of my load balancer, my firewall, port 80, and then port 443 as well. So anything that comes to this public IP with port 80 goes to this Istio, right? And you don't need multiple firewalls. If you have, let's say, another cluster, you want to use the same firewall, you just add another public IP for that, right? You can go up to 250 public IPs and keep the port 80 and 443. And you can always obviously change the ports, something else if the firewall is not fully public, and then use a different WAF or an app gateway or something in front of it, right? This is the example where I just create a pod reader role in the default namespace, and then I'm assigning here. If you see, there's the reader UID. This is how I would assign it, a role binding to the pod reader role in that namespace. This is also it's all in preparation for the test cases. I don't know if you took a look at the repo. I will go at that. I'll showcase that, but it's just all these tasks will help with testing it out and seeing the functionality, right? I'll just try to compress as much as possible into one deployment. This piece will just create the jump box. It's just a VM and so on, and then add a DNAT rule port. So I'm actually using the public IP of the load balancer, but with port 2222 and translating it to 22. Okay. And if you see here, I'm only allowing my public IP, and I will show you that it doesn't work otherwise. And the last one is I'm allowing an outbound rule here for the jump box to reach dev.azure.com. So that's actually very helpful. And I'm on, as you can tell, the source is only the jump box subnet, not the AKS. So the AKS cannot reach it, or any other workload in the VNet cannot reach it either. I'm only allowing this. And so let's assume that the jump box, for example, is actually an Azure DevOps private agent, and I'm allowing it to reach Azure DevOps. So when it comes to the Istio profile, just to run through it quickly, this is the operator for Istio if you want to deploy it. In 1.4.10, and I think after in 1.5 and above, you don't need to give SDS as the default, but this is to deploy with the profile of SDS. So STU has a software, it's called a Secret Discovery Service. It's really nice. All you have to do is create a TLS, a Kubernetes secret of type TLS in the STU system, and then your STU gateways can pick that up automatically and use it as the TLS for your your ingress into the cluster, and as well as other things, like it helps with the Citadel functionality and so on for the MTLS and distributing the cert. So some of the customizations are being done here is, first of all, make sure it uses Linux nodes. Then I'm enabling the MTLS in the control plane. This also enables MTLS everywhere, so all services have to use MTLS. So this will add a global policy of MTLS enabled. This will also auto-enable MTLS on any namespace you add. Then for STO proxy, I'm just sending the logs to dev standard out to avoid filling up the ephemeral storage on the nodes. I like to add a delay on the readiness probe of STO proxy because I've noticed sometimes it takes time to come up as the STO proxy sidecar. It takes more than the default 1 second or 2 seconds to be ready. So this helps with avoiding like getting some errors in the messages that, like 503 error that it's not ready and so on. In case especially if you're going to add your own probes as well. Sidecar injection also, this is a piece where this is needed if you want to have your probes, like liveness and readiness probe for Kubernetes, to work while MTLS is enabled. Otherwise, they will keep, because the probes come from kubelet. Kubelet is not part of your service mesh, so it will fail. All your probes will fail. So this will actually, it's a flag. I don't know the full internals, to be honest, but this is the flag recommended by the STU community to redirect the probes to, without going through the MTLS pretty much. So technically kubelet is trusted. Everything is running through this, monitoring all your pods and so on. It's on your nodes. So it gets to the probes will function properly with this. Otherwise it would not. And then this is the gateway piece. And this is where we're adding that annotation to make sure that I'm going to use an Azure load balancer as an internal one. And then I set the external traffic policy to local. This would be essential if you want to preserve the source IP of your clients. However, in the case of an Azure firewall, unfortunately, you will always get the firewall as the header. It will never give you the source of the client. You will have to go to the firewall logs and look at it and see where it's coming from. And finally, there's the enable SDS on the ingress gateway, so it can handle the TLS certs from Kubernetes secrets. And these pieces just enable Grafana and Jagger and Kiali. And the security also enables node agent because it mounts the certificates with secrets in every node. You can use it as it is. You can alter it as you see fit, but it works. I've tested this multiple times, and it's functional. And if you have any issues, feel free to reach out or add any issue on the repo. The other script I have for testing is a very simplistic one. It's just a sample deployment. Again, it's very simplistic, as I'm mentioning. I just pass these, I provide these at runtime, like it's just pass it through. It'll ask you for the ACR, the AKS resource group where you have deployed it, the AKS name, the namespace. It could be linked with the other one, and it just picks up the names from here, but I just figured I'll keep it dynamic because in case I want to deploy multiple environments and test each one on its own or so on. You give it a domain, so pretty much something like this, and a subdomain like, so it's going to be book. So that will make sure your FQDN, your service will be exposed at bookinfo.codethecloud.ca, right? So in this case, I'm actually generating my own TLS cert. So I create a CA and a private key and so on with OpenSSL, and the script works if you have all of these enabled and downloaded. And again, the script has been tested on WSL1 with, I think, bash 4.4. something, but 21 or something like that. It's there in the README. I actually now remember the requirement for OpenSSL. And the script just runs out of the box as it is. It deploys an Nginx image, it deploys the book info application, the STO gateway, all the templates are in place. I think we're getting close to that time. I don't know if you're available for a bit longer, but I would like to demo some of this. Or Max, or if we can move to QA if there are any questions, or I can just try to demo some of these features.
I'd like to see them. I don't know what everybody else thinks.
So I'll just run a sample deployment, I guess. So if you can tell, this is what gets deployed if you run the script. So you'll have a one demo resource group and one network resource group where all the network components live, the firewall, and this is the workbook. I'll go through it quickly soon, but this is my resource group with my AKS and the ACR and so on. In the ACR, I always add like a timestamp on it that helps me keeping the name unique to a certain extent, unless you're unlucky. So AKS is the name of the AKS. Namespace to use, I'll just use test as the name of the namespace, code cloud.ca, work info. That's pretty much it. So you see it logged into the AKS cluster, but it will ask me to verify with my AD identity, right? So I have to log in. I could have bypassed with admin, but I wanted to showcase this. And in this case, I will go ahead and this is my main user. The other one is only a reader. Hopefully I'll have time to show that, but again, if you feel free to go through the repo, you will follow everything. And so I pretty much deployed everything. So if I get namespaces, if I get the namespaces, you see the test namespaces there. I get everything in the namespace test. You will see all the pods are now running. It was able to pull it from.
Is it your
sorry?
Is it your internet? There's a bit of a gargling noise.
Sorry, I don't know. Can you hear me now?
I can hear you fine, but every time you say something in a sentence, it's a bit of a noise.
Oh, that's weird. I'm not sure.
It's okay, keep going.
Yeah, no, so as you can tell, the source of the image is my ACR, and it's working fine. And it's all ready. I think probably I should be able to route it. So again, this is a very basic setup, but I'm just using my host file with that endpoint, and I will go ahead and browse to that, and it should be reachable for me. And just to show something, this is the public IP of my firewall. It's not a public IP on the cluster or anything. So this is the firewall, public IP. This is the public IP of the firewall. So this is not reachable because it's not found that it's not reachable, but it's hosted at product page, right? It's gonna show not secure because it's self-signed, but as you can see, this is the one I just generated, right? This issued to and this is the CN, the subject, this is the organization, and this is the CNF set, right? So that can always be altered. Yeah, so, and this is all working, right? And the script actually deploys some network policies allowing things in place. So if I get the network policies in the test namespace, hopefully this works, as Istio tends to cache stuff. But if I delete this, so if you see, I have a network policy, and you can go through the templates, but I have a network policy to allow the ingress from Istio. So I have one that denies everything. So it denies all ingress. And then there's one that allows, so it builds on top of it. There's one that allows traffic only within that namespace. And there is one that allows ingress from Istio as well, from the Istio components and the Istio namespace. So what I will do is I'm going to delete the network policy for allowing, for allowing Istio ingress. And I'll wait a bit, and this should eventually fail. And in the meantime, I will I will show also the functionality of the policy within the namespace, right? So if I go to the reviews pod, and if I try to curl Nginx, oh no, sorry, it's not the reviews, it's the ratings. That reviews doesn't have curl in it. So ratings. So if I curl Nginx, I have an Nginx service running, right? I deployed a pod and created a service for it just within a cluster IP, just within the cluster. So if you look at this, it's just an internal IP, right? It's just going to this internal IP, and it's able to reach it without any issues. So if you go back to this, I think it should be, it's still working. Just give me. So as you can see, I think it's failing to load now. So see, this is an error from Istio. So it's not able, Istio is not able to route to that backend service because I have blocked from the network policy. And you see here the Nginx is, I'm able from one pod within the cluster to reach that Nginx, within the namespace, I mean, in that cluster, to reach the Nginx in the same namespace. But if I'll keep this one open actually, and I'll go to another window. So network policy in the test namespace. And if I delete, again, if I delete the policy that allows the inter namespace communication, and if I go back here, it might take a few seconds. See, now I'm not able to reach it because there's a catch-all that denies everything. So as you can see, it's being blocked. What I'm going to do as well now is remove the catch-all that denies everything, and I should that communication should be restored. These are all samples. It's pretty basic stuff, but you can build on top of it for sure. So you can see the communication has been restored now. That's within the namespace, and then this one should now also work. As you can tell now, it's working. So it's pretty straightforward. It's fast. Sometimes you might see some delay for a few minutes, especially when you have Istio and service mesh. It tends to cache some stuff, but if you delete your cache or so on in your browser, it works pretty well. Another small test I wanna run. I know it's taking time, but it's actually a nice feature about Istio. I'm gonna edit the deployment in place. So I'm gonna edit the ratings. I'm gonna edit the ratings deployment. Okay. And I'm gonna exclude it from. I'm going to exclude it from the Istio service mesh, so it will not have a sidecar. Okay. So if I add annotations, I think it's sidecar.istio.io/inject. That's what I remember. Hopefully it works. It's there in the documentation in the README of the repo as well. So now, okay, so that's working. So you see now it's running with only one container because there's no proxy in it anymore. So if I go back to the exec command, but it's going to be a different pod. So it's going to be the 6F. So now if I try to go to the Nginx, I actually directly get rejected because I'm not part of the trusted service mesh anymore. This pod is not there anymore. So it doesn't go through the proxy because every pod in the service mesh will have a sidecar proxy. The communication will always go through that proxy. Everything gets routed through it, outbound and inbound. So it's going now directly through the overlay in the AKS cluster. Is going directly to that, but it hits first the proxy. The proxy directly rejects it. So it's directly being rejected. One more thing I would like to show is, I don't know if I have it here. Yeah, so this is the endpoint. If I try to, and this is about the minimum TLS version. So I'm going to try to reach out to that endpoint over, as you can see, I'm able to reach it, right? So I'm able to reach it over TLS 1.3. If I try 1.2, it works. Now, if I try 1.1, it's being rejected because the version is not accepted by STO. If I try 1.0, it's going to be rejected. And if I try SSL, it's going to be rejected. So all of these features are helpful. I'm not sure exactly what. There is a bunch of more test use cases that can be done with the current setup. All of this is in the repo. Feel free to do it with some examples and everything to do. The RBAC piece, I can showcase that. Before I go to that, I'm going to do the SSH to the jump box actually. So let me show that. SSH JB user. So as you can see, and it's using my SSH key because I'm adding that to the VM, right? So if I switch on my VPN, and I might get disconnected, I think. I'm not sure. But let's see. Can you still hear me, Max?
Yeah, I see.
Yeah, okay. So, so my public IP has, hello? Yeah, so my public IP has changed now. Can you hear me, Max? Just to confirm, because I think it switched the VPN.
Yes.
Yeah, okay. Hello?
You're still there?
Hello? Yeah, I'm here,
Okay.
Okay, so as you can see here now, if I try to SSH again, I'm not able to because the firewall DNAT rule is only allowing specific source, which is my previous public IP. I'm not able to reach this jump box anymore. And I'll keep the VPN on and just do another test, which is I'm gonna try to reach to get the nodes on the cluster, and I'm not able to, and I will just run it with a bit of a verbose output. You'll see it's actually sending the request, but it's going to time out because my IP is no longer there allowed in the IP whitelisting that is there. So it works really well. All of these features work. If I'm gonna switch back and switch off the VPN, it should it might disconnect a bit. Let me know if it does. Okay, can you still hear me?
Yes.
Yep. Okay, that's good. So I'm just gonna jump back into the jump box, and if I go to google.com, for example, I'm not able to. It's not able, and you can see you get this alert, right? It's denied. There is no rule match. This comes back from the firewall directly for you. So if I try to go to dev.azure.com, which I have a rule to allow, and as you can see, it's going through, and it's just giving me a redirect because it's HTTP. I should go to HTTPS, but so on. So it works, right? So one more thing to do is if you want to test the Microsoft threat protection, it might take a few minutes to show up. I already tested it, and I would like to show the workbook actually that gets deployed, and it's really nice and it's extremely verbose. So this workbook relies on the diagnostic settings that are enabled on the firewall. So I'm going to choose the workspace where I want to read from. This is a security firewall, the name of the firewall. You can see all the events are being traced, like all the metrics of how many events have come in, utilization of the source netting, port utilization. It's pretty low, but you know it increases a lot as you add more clusters, and you cannot use only one public IP for that. So all these metrics are there. Things of interest are like this is also the application, right? So it shows here, you know, default action, which is to deny. So many of them get denied. Right? This is all the testing I've been doing in the last few days. Right? So it shows you all your rules and how they were matched. This is the service tag. It was matched like 194 times, and the last time it was matched, and so on. Right? All the metrics as well. Some stuff might be missing, but it shows you also all the FQDNs, right? So you can typically, for example, add it, if you don't know what sources you will be reaching out to, you can add an allow all rule or a bunch of rules that do that, and then you look at these metrics and see and gather the FQDNs that you're reaching out to, right? For example, it shows you all the last 250 rows, right? Which one, what protocol it was, what the source IP, this is a private one of the pods, was trying, the port it tried on, and the target pod, and if it was denied or allowed, and so on, and the protocol used. It's really nice.
How long was the delay between connection attempt and what?
I would say a few minutes, because all it needs is to just send it through Azure Diagnostics to Azure Monitor. Usually, typically, the delay between what happens on a resource in Azure and what shows up in Azure Log Analytics is a few minutes. There have been cases where it could take a few hours, but it's a rare case. And usually, you talk to support and they fix that. But what I notice is always a few minutes. It's pretty fast. So network, also, this is the application rule. You can see the network rule log. Same thing, shows you all the ports, the sources, what was a DNAT rule, what was a deny, what was an allow. You see all these public IPs. This is my public VPN IP. This is what I just tried, right? And it's already showing, by the way, Max. This is my IP, what was on the VPN, right? It showed that it got denied on the SSH. So, yeah, 9 times, all the attempts I did, right? So the actions, again, also a list of all the rules show up. Yeah, so this is, I'd say there's 5 minutes here showing, or I'm not sure. Yeah, I'm not sure exactly. This shows a bit of a delay, but you can refresh and check. Then there's a DNS proxy feature on the, this goes hand in hand with the network rules that use FQDNs. Again, you get all the logs. It's very verbose. The last thing I would like to show is this, the investigation, which is really nice. Again, it shows you all the FQDNs that have been allowed, denied, how many times. You can obviously, this is all a visualization kind of situation. It is available in Log Analytics. You can build around it alert rules and so on to alert your teams if anything shows up that is malicious. And also the FQDN lookup that has been happening and what has been denied and allowed. And at the bottom, there should be the threat intelligence. So yes, there is a threat intelligence here. So from Microsoft end, on the inbound, most of the stuff actually gets filtered out before it even reaches your resources by Azure, if something is malicious that's coming in. But, and so on the Azure Firewall, it states in the documentation that they do not monitor all port scanners. Like, you're not gonna see it from all port scanners. It's gonna be only from anything malicious or, that is known and monitored by Microsoft in general. But one of the tests you can do on an outbound perspective is to run this, and you try to reach out to this endpoint. This is stated in the documentation. You can try to reach out to this endpoint, and I've attempted this on a few of the pods and so on, from pods, from the VM as well. And you can see that it shows the alert. This is a test indicator of a Microsoft-owned domain, but it just shows you that the alerting on the threat intel works, and this is the destination you can see that we reached out to. So unless you get attacked, you cannot really test it extremely. You can do one thing is add DNAT rules that on port 22, for example, that allows any source. Then you might see something if Microsoft is not filtering out the sources from China or Russia or so on. But in general, it should show you a lot of information, and it works really well. So, and again, this is a pre-built workbook. You can build your own. You can leverage solutions from on workspace as well, on the Log Analytics workspace. So, yeah, I think the last thing is the RBAC test, if you want me to do that, or if I think I already crossed the time. But it's up to you, to the audience. And hopefully this has been helpful.
Yeah, I think that's a lot of information. Let's save it for the next time.
Yeah, no problem.
Then thank you very much. Anybody
no worries.
Questions? All right. Thank you very much, Ahmad. It was great. As always, the next talk we're going to have is in second Thursday of the month. Not sure what that's going to be, but it's going to be something interesting. I'll post the topic later. If you have any questions, comments, or would like to know, learn or know about something, please let us know. And again, thank you, Ahmad. Thank you, everybody, for attending. Have a good evening.
Thank you. Thank you, Emma.
No, thank you.
Bye.